So next last bit on this block is intermediate shaft. Now on the 8 and 16 valve engines, 16 valve, timing belt end, runs across, drives the gear and does the oil pump. On the 8 valves it just drives the distributor and the oil pump. So I was just going to have a nose at the measurement on this. They've got an end flow tolerance of about 0.25mm, which is next to nothing. There's not a lot to worry about on these. But I just went to have a nose at it, and as you can see there, you can't, that bit there sticking out is the bearing shell which wears, which I was going to talk about. So the likelihood of that doing that is because the timing belt has been too tight. So you've got the timing belt, rubber timing belt on that end, you've got too much tension on there, which is pulling this shaft, and obviously leverage, you've got too much on the shaft, that shaft is going to push that way or the other way, hence why that bearing has done that. They're quite simple to come out. You have to turn it round. There's 2 bolts, one there and one there, so I'll just crack those off, take the pulley off, bolts off, seal off, and then I'll pull the shaft out. So pulley's off, the end cap is off, and then you're just left with the shaft there. So all you want to do is gently pull it. It's going to be a bit of a strain on this one because I've got that bearing there. Ooh, there we go, she's out. So hopefully there's no damage to that, which is the main bit. Bearings you can change, you don't want to mess around with the shaft. Don't look too bad that end. That end again. You've got a bit of broken shell there. That's alright, not worried about that. Again, when you're taking things apart, always good to lay them out. Pulley, bearing, shaft, done. Also, once you pull the shaft out, you've got the gear down there. So all you want to do, just fish the gear out. Now this is the gear which splines on the inside of there, splines on the shaft of the oil pump, and then obviously aligns with that gear on the side of there. You'll struggle to get wear on those, doesn't look too bad. So that's that there. And now we have got the issue of that shell coming out. Let's have a look at this end first. There we go, yep. So my other engine, the KR that I've stripped, these shells are absolutely bob on, no worries with them. And as you can see, these are absolutely mullered. So, and these shells are a bit of a pain to change. It's doable, it's not hard, it's just a bit of a pain. But yeah, they're definitely past it. That's the, what looks like the first sort of main layer. It's gone round, spun itself round. That looks terrible. And then that one inside there, it looks like that's probably a perfect description of what I was trying to explain. Is you've got the timing belt this side, so you've got the timing belt too tight, there's too much tension on it. So you've got too much tension. When the timing belts are tight, these bearings and stuff in the design process are only designed to work at X amount of pressure on the belt. So if you've got timing belt too tight, there's too much pressure pulling on this cam that side, so you've got too much pressure going on there, and obviously the bearing clearly can't cope with it because it's falling apart. And now the rear one hasn't fallen apart, but it's worn down that much, it's gone that thin, and it's pushing itself out. So again, with the basic leverage, you've got too much strain on this end, pulling the cam in that way. So if it's going that way, the back end of that is going up that way, which is going to cause accelerated wear. So it's quite good it's actually done that. So I'll try and get those out now and see what they look like, but they're a bit of a mess. But it's good job we found it now than later on. So that's the bearing race nearly out. Now the way I've done this, big socket, whatever size it is, yeah, 1 1/4 socket, which is big enough to sit inside there, enough to catch the bearing race to push it out, but not enough to wedge between the actual housing. So I'm just gently tapping that, and that'll come out. The awkward bit is when you can put them back in. This one's fine because obviously you can do it from this way, but the one out there, the other end, you've got to try and get that sort of inside the block. So you've got to try and get some kind of socket or tool, probably put that through that side first into there, get an extension bar on it and just tap, 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 tap till that one sits in there. Bit awkward, bit fiddly, but it's not hard to do. So I'll just pull that right out. And as you can see there, so I've just got the same socket, that bearing's out the way now so it's to fit for the hole, a couple of extensions down there, and then just knock this bearing out. So as you can see, that's worn down. Zoom in, there we go. As you can see, it's actually spun itself around. So that's actually blocked the oil hole up, where the oil would go through. Yeah, so that oil hole was probably in that gap inside there. So well and truly mullered. But they're out, no damage to the casing or anything, so it's just a case of new showers when it goes to rebuild. So that's the engine completely in pieces. It's got oil squirters in there, don't need to take them out, not worried about those at the moment. So the block needs to be overbored, either to 83mm or 83.5mm. That's fine, that's what the block needs. Auxiliary shaft needs two bearing races, and that can go back in with a new seal on that cap. Boom, that's done. Crank needs a polish, double check all the bearings, races, get all them, they can go back in with the new seals, top and bottom. Pistons, there'll be new con rods on there, new bearing races. Again, I'll lighten and balance those, as do with the other ones. New ARP bolts in the bottom of them, new set of pistons to match the bore, piston rings. Wobble that back together, and that'll be the bottom end built up, ready to go. So all I'm going to do now is just put things back in lightly. So I'll put the shaft back in, put the crank back in, all the bits back where they should be, not tightened up, just in there, nipped up. Again, because it's going to be transport mode. I'm just going to put one of the piston rings. That's the second compression ring on all of them. I'm just going to put those back on them, so when they're in the bore, they're not banging around, if you know what I mean. So they're nice and tight. So once all that's done, it's moving on to the head. So again, I'll do this as a separate video, because this is quite a big problem that a lot of people don't realise when you're doing your timing belts. People say it could be wear, but it is purely, when you think about this in a logical approach, you've got X amount of pressure on there holding the shaft, oil pressure, and you've got bare oil on those two. You've got too much pressure on that side, or too much tension from the belt, pulls that too tight against its housing, hence the bearing shell does that. And again, on the other side with the leverage, you've got it pushing up, and you can see that it's done it because it's pushing up, it's putting too much tension, it's worn it down to the point it's that flimsy. I can just bend that. So it's worn it down, it's that flimsy, and then it's turning itself around, which shows you how much pressure is being put on the end of that shaft, because that end's too tight. So if you've got that end too tight, the whole shaft is doing that in the engine. So excessive wear that side falls apart, that side has gone thin and obviously pulling itself apart again. If this isn't caught, those bits will get into the oil ways, into the pump, into everything, and that's when you're going to cause problems. So it's one good thing to always make sure your cam belt, or your timing belt, whatever one you call it, is at the correct tension as stated in whatever manual we're working from, be that the Bentley or the Haynes. Again, these have got a 3.25mm end float, which is on that face, the face on there to the face on there, because you'll have oil pressure coming through, going around there and going out. You've got an O-ring around there to stop the oil getting out. If you've got, I just moved it by hand, it was barely nothing, so I'm not too worried. Plus there's no oil pressure in there, so it's okay. If you can, with it all dry, if you can move that shaft and there's a lot of play, you can just change the end of these and get the new, because that's the surface that wears. But we're not too fussed on that, that's good. There's not a lot of wear on that either, just the general wear, which is fine. I mean, if they're cheap enough, you might as well stick another one in if you want to, but again, if you start doing that with engine build, that's how the cost goes up. So, timing belts, simple one, make sure they're the right tension, otherwise you're going to run into those problems. Luckily on, like say, my 8, the 1.9 that's in there, they were both perfectly fine. Measured up thickness wise, either end was bob on, so I haven't changed them because there's no need to. Like I say, you don't need to change stuff for the sake of changing it, unless they're obviously falling out like this. So this is a perfect example to show you why they do it. So that's worked out pretty well, to be honest. So nothing too major with this, so I'll get that edited, this edited either, and then yeah, I'll start putting things back together, and then we can look at the old head.